A century ago, electric vehicles like this Cuyahoga runabout were niche luxury items, confined mostly to wealthy city dwellers. The engineering math simply didn't work out. Early lead-acid batteries were heavy, and the energy they provided couldn't justify the dead weight required to move the vehicle. Because demand was low, suppliers only built these battery packs in tiny batches. This lack of volume kept prices high, trapping the industry in a loop of expensive, low-performance components. To break that loop, Tesla realized they couldn't rely on existing supply chains. They had to design the machine that builds the machine. That led to the concept of the Gigafactory. This wasn't a standard assembly warehouse, but a single, fully integrated tool engineered to operate at an enormous scale. Mainstream EV adoption required solving a logistics challenge, turning massive piles of raw dirt into hundreds of miles of driving range as efficiently as possible.
The pipeline starts here, at the beginning of the supply chain, where raw lithium is harvested from vast evaporation ponds. To make a modern battery work, that lithium is combined with millions of tons of other refined powders, like nickel and graphite, pulled from heavy open-pit operations across the globe. Once inside the factory, these dry chemicals are blended with liquid solvents in industrial mixers to create a perfectly balanced, thick paste called slurry. That wet slurry is then precision painted onto ultra-thin sheets of copper and aluminum foil, coating both sides evenly as the material rolls through heavy presses. If this painted layer is even a fraction of a millimeter off, the entire battery fails. This thickness dictates the energy density of the cell and the final range of the vehicle. Now those coated foils are assembled. Machines lay down a copper anode sheet, place a thin plastic separator on top to prevent short circuits, and cap it with an aluminum cathode sheet. This flat metallic sandwich is fed into a high-speed winding machine that tightly spools the layers together into a dense cylinder known as a jelly roll. That rolled core is immediately dropped into a hollow steel can, which gives the battery its cylindrical shape. Automated nozzles inject a liquid electrolyte into the can to allow energy flow, and a heavy press crimps the metal cap shut to permanently seal the cell. This entire sequence happens in the blink of an eye. The machines execute this delicate assembly millions of times every single day. Achieving profitability meant scaling this exact robotic sequence to run at a blinding speed without triggering a massive failure rate. But a single battery cell cannot move a vehicle. It takes a massive amount of concentrated power to push a 2-ton car down a highway. Robotic arms grab these individual cylinders and group them together, bonding thousands of them side by side to form solid structural modules. Packing thousands of active chemical cylinders this tightly creates an immediate engineering danger: extreme heat buildup during driving and charging. To manage this, automated machines weave flat, liquid-filled cooling ribbons between every row of cells, constantly pulling heat away and regulating the temperature. These stabilized, temperature-controlled modules are then hoisted and locked into a massive, flat rectangular tray that spans the length of the car. The finished assembly acts as a high-density, liquid-cooled power grid, harnessing thousands of individual chemical reactions through a single networked system. This strategy allowed for a new vehicle architecture. Instead of placing a battery inside the car, this rigid pack became the structural floor pan of the chassis itself. By refining every step from chemical mixing to final module assembly, Tesla drove down the production cost of every kilowatt-hour. Lowering battery costs at the factory level was the only way to make electric vehicles affordable enough to challenge the dominance of gas cars. A good battery chemistry works in a lab. Taking that chemistry, wrapping it in steel, then cooling it, and repeating the process millions of times a day is what actually put electric cars on the road.